Association versus causation. So this time, or as we're talking about these scatter plots, and we're talking about how these variables relate to one another, one of the things you may have noticed, I talk about relationships and associations. Relationship and association mean the same thing. Okay? So when we look to see if two variables have a relationship, we're looking to see if the two variables have an association. Okay? And that does not mean that that association is necessarily cause and effect. So when we say there's a very high correlation between variable 1 and variable 2, that means they seem to be related somehow, but it does not mean that variable 1 causes variable 2 to change. So remember last week when we talked about explanatory versus response variables, when we identified the difference, we were to look at the two variables and try to determine of the two variables, which one would likely cause a change in the other. Okay, so it's something that we were like, well, if we feel there's a cause and effect, this one's going to be the cause, this one would be the effect. We did not say the explanatory definitely caused a change in the response. So when we talk about correlation, and that's one of the things, a lot of times when you see people report stuff in the news or in advertisements and things like that, they say there's a really high correlation between these two values, and they imply that that means a cause and effect relationship. They're saying that if variable 1 happens, variable 2 definitely will too. Okay, and that's not what we mean when we say correlation. Correlation is a relationship. It is not necessarily cause and effect. Okay, so this needs to become kind of your mantra. This is something you need to tell yourself over and over and over again. When you see the word correlation, it does not mean there's a cause and effect there. It's possible that there's cause and effect, but correlation itself does not guarantee cause and effect.
So what other relationships do that correlation represent?
It just means that they happen to be like as one goes up, the other goes up, or as one goes up, the other goes down. It's just saying that there's either a positive or a negative association. They might mean that there's a partial cause. So maybe there's some of what the x variable does causes a little bit of the y, but there might be something else in the background driving that relationship that we see. So when we say that there's a correlation, we know that something's happening, whereas x increases, y goes up, or y goes down. But we don't know always for sure if it is a cause and effect, if that x variable is the only thing that's actually affecting the y. Does that make sense? Okay. So here's a quick example. I kind of gave you one last week too, but here's the example. A study's done at Hickory Hill Elementary. The results show that the association between shoe size and reading ability is strong and linear, with a correlation that's very close to 1. So based on that information, should we just start buying kids bigger shoes to improve their reading ability? Okay, so notice we have two variables. We have shoe size and we have reading ability, right? Now when we put the two together, there is definitely a relationship there. As shoe size increases, so does reading ability. And in fact, they tell us it's very strong, linear, and has a correlation very close to 1. That means it's an extremely strong relationship. Okay? But at the conclusion, do bigger shoes cause higher reading abilities? No. So what's happening here? What might be an explanation for this relationship we see that would explain why as reading or as shoe size increases, so does reading ability? All right. If we look at kids in an elementary school, as they get bigger, they start wearing larger shoes, right? And as they're getting bigger, that means they're getting older. They've had more schooling, which means their reading ability should be increasing as well. So what's happening here is, while shoe size and reading ability have a relationship, the shoe size getting larger is not causing the change in the reading ability. More likely, it's the age of the kid and how much schooling they've had at that particular point. Does Does that make sense? So this is the type of thing, and people will try to do this. They'll try to make or drive their agenda using this idea of correlation. You have to be able to sift through it and decide, well, is that actually the case, or might there be something else happening that's driving this trend that we see? All right? So in this example, when we talked about the age of the kid and the amount of schooling they've had, that is an example of what we call a lurking variable. This is a term you definitely need to know. A lurking variable is any variable that has a very important effect on the relationship between two variables, but it's not a variable that we measured in the study. So it's a variable that kind of happens in the background. It's something that has an important effect on the relationship between the variables we're studying, but it's not a variable that we actually included in our study. So like in that last example, we looked at two variables, shoe size and reading ability. There was definitely a very strong association, very strong relationship, but lurking in the background was a variable we didn't measure. The kid's age or the kid's schooling at that point, how much schooling they've had to that point. So there was something in the background driving the relationship we were seeing. That's what we mean when we talk about lurking variable. Okay? So when you see a relationship between two variables and you're talking about a correlation between them, you have to ask yourself, is it specifically these two variables that have the direct relationship, or is there something else that might be driving this relationship? Something else that might be factoring in that we haven't included. Okay? So for instance, here's another example. A study was done a while ago dealing with discrimination in medical treatments. So these people went into the hospitals, they were looking at how men and women were treated based on certain conditions and complaints, so symptoms. So the thing they looked at specifically was chest pain. So what they did was they identified, okay, men come in with chest pain, here's what they had happen. Women come in with chest pain, here's what happened with them. And what they were trying to decide was if there was any discrimination going on, because what happened with men, when men came in complaining of chest pain, they got very detailed tests, and in a lot of cases got very aggressive treatment, maybe open heart surgery or something to that effect. But when women were coming in complaining of chest pain, they ran fewer tests on them and gave them much more moderate treatment. They weren't as quick to jump into open heart surgery or anything like that. They were trying other things first. And so they're trying to decide, well, are these doctors trying harder to save the men than they are the women? Or what's going on here? So what do we think? Can we identify maybe a lurking variable that would drive this relationship that we're seeing here? It can be, yes. They are at higher risk for heart disease and things like that. But I mean, that being the case, would that necessarily cause us to treat men more aggressively than women, per se? So, like, even though women don't have it maybe as often, why would they maybe not be getting the same treatment when they do?
Don't they like kind of expect the women to like have kids and families, so they like need to like more keep the women like safe than opposed to like the men?
Could be. Okay. So we got something like that. Autumn, you were kind of close with yours. Think about when men start having heart issues. When does that generally start happening? You guys had any experience with like either dads or grandpas or anything like that, kind of having some heart issues, like they start getting like high blood pressure or things like that? When do guys generally start having heart conditions? Well, so when they're older, but about what age? Okay, so probably about their 50s. There have been cases like in the 40s, people are starting to have issues, okay? So maybe like 40s, 50s, 60s, right? When do women typically start to have issues with their hearts? Quite a bit later. Women tend to have heart issues later on, maybe late 60s, 70s, 80s, and things like that. Okay, so men in general, and again, these are trends, they're not rules, but men tend to start having heart issues earlier in life, right? So if you have a 40-year-old, 50-year-old, 60-year-old male coming in with chest pains, they're still young enough that aggressive treatments, detailed tests, invasive procedures are still okay. They're still likely to be able to recover from that pretty easily. But if women are coming in late 70s, early 80s, now we start hitting some riskier times. Okay, they're not as likely to be able to handle aggressive treatments like open heart surgery and things like that. So we try other things first and go to open heart or invasive procedures like that as a last resort. Okay, so in this case, a lurking variable might be something with age. When the guys are coming in complaining of chest pain might affect how they treat them. Same thing with women. Okay, so while they were trying to show that there was discrimination between them, they weren't looking at the fact that, well, women were coming in at a much later age than men were, which was probably the driving force behind the decision making. Okay with that? All right. So, lurking variables in advertising. Let's take a look here. Oops.
Dad.
Hi.
Looking good. You've lost some weight.
Thanks. You noticed?
You know these clothes are too big now, so I'm donating them. I'm not going back there again. Good for you. How'd you do it? Eating right? Whole grain. Whole grain?
Whole grain. People who choose more whole grain tend to weigh less than those who don't. Multigrain Cheerios has 5 whole grains and 110 lightly sweetened calories per serving. More grains, less you. Multigrain Cheerios.
All right, so what's happening here? What's the implication, Kylie? All right, so they're saying, hey, if you eat our cereal, you're going to weigh less. I mean, that's the overall message that you're getting from that, correct? So what are they saying here? Did anybody catch the phrase specifically, kind of towards the middle? There we go. People who eat more whole grain tend to weigh less than people who don't. So what are they implying there? Well, you're throwing the lurking variable in with your explanation there. They're saying that if you eat whole grain, what's going to happen? You're going to weigh less. Okay? They're implying a cause and effect relationship. You eat whole grain, you weigh less. Okay? But think about that. What if you eat an entire box of cereal for one breakfast, one meal, and you do that every day? Are you going to be losing weight? Probably not. But you're eating whole grain, and they said if you eat whole grain, you're going to lose weight. So what's going on here? What are some things they're not accounting for, that they're not putting into this? Serving size, how much you're actually eating, right? What else? Activity level can play a part in that. And when they actually said specifically, people who eat whole grain tend to weigh less, they're saying that the implication is if you eat whole grain, you weigh less. But what's probably happening there? What type of people tend to choose whole grain? People who are already into health. They already choose to eat the right things. They probably exercise quite a bit. So they already have a certain lifestyle that lends itself to them being lighter, right? So what they're doing here is they're glossing over the fact that eating whole grain doesn't make you weigh less. It's basically a lifestyle. But advertising does this all the time. They say that if you do this, you're definitely going to have this happen. and they leave out those lurking variables. They imply causation. Eat whole grain, you're definitely going to weigh less. But like we just talked about, serving size can play a huge role in that. Your activity level, I mean, you could eat this every day, but if you don't exercise at all, are you really going to be weighing less at any time? Probably not. So with advertising and things like that, like as you guys watch commercials and TV, start looking for things like that. You see it all over the place, where they tell you one thing is going to definitely cause a change in the other. They're using this idea that correlation and causation are one and the same. So you got to be real careful with how that happens. So here's a last little thing, a cartoon that kind of helps illustrate the difference between correlation and causation. So in the top example, correlation, 100% of people who breathe die. Okay, so a very high correlation between breathing and dying. Does breathing cause you to die, though? No. So there's a relationship there, but it's definitely not cause and effect. You breathing is not going to cause you to die. Okay? On the bottom, though, we have causation. 100% of people who don't breathe die. So if you stop breathing, are you going to die? Yes. There we can have cause and effect. Okay? So correlation, again, simply means there's a relationship there. It does not imply cause and effect. You have to look for those possible lurking variables as a way of having that relationship come about. You okay with that? All right. Last thing here, this idea of averaged data. So this kind of fits in with our correlation unit here. When we have correlations that are based on averages, if we have a correlation that's based on averages, we cannot use that correlation to correspond to individuals within the study, because the correlation is going to be much higher for the average data. So kind of an example here, the S&P 500 index, that's like a stock market thing, kind of like Dow Jones. Okay, so it's a market that people can get into to invest in. And so when you look at like Dow Jones, when you look at the S&P 500 index, what you're looking at are averages. Okay, so what they do is they monitor stock prices for a specific company over a period of time, and they take the average stock price as their information. So each day, their stocks are rising and falling, right? And what they're looking at is what's the average that it either rises or falls over a given period. And so when they report their gains or their losses in that stock market report, they're looking at the average. So if we think about that, and we're looking at the value here, we might get something that looks like this. So over time, their individual days are up and down. They're all over the place. Some days they're going to gain, some days they're going to lose. Some days they gain a lot, some days they lose a lot, or maybe gain a little or lose a little. Okay, it's going to be all over the place. What they're going to do is take all of this information over a given time, and they're going to average it. So what were the average gains or average losses? So if I take all of this really varied data and I average it together, it starts to become a lot closer together. The differences we see are less and less. So the correlation I get when I average is going to be a lot higher because my values are going to tend to follow a form a lot better. So when we look at things like this, when you see something about an average data set, your correlation is going to be much higher than it would truly be for individuals. Okay? So if instead of looking at averages, we looked at all 500 individual stocks, our correlation for the individuals would be much lower because now we have values jumping all over the place. Whereas with the average data, it's only jumping a little bit here and there because we're looking at averages. Okay, so if they give you a scenario, they're saying here's some average data, here's the correlation for it. If they try to apply that correlation to individuals, that's incorrect, because that correlation is much higher than what it would truly be if we looked at the individual information. Okay with that? All right. So your assignment is going to be a worksheet today. When you get the worksheet, put your name on it. And then get out your calculators. Because we talked about how to create scatter plots last week. But we didn't talk about how to create a scatter plot on your calculator. So on the worksheet here, questions 1 and 2. On questions 1 and 2, you need to create your scatter plots by hand. So you need to actually create your own scale for X and Y. You need to plot the points manually. Okay? So you need to do all of that by hand. But if you look at questions 3 and 4, they want you to sketch the scatter plot. So basically, when you're asked to sketch, you go to number 3. Okay, we'll just kind of do that one together so you can kind of see what I mean here. So when they ask you to sketch the scatter plot, it means do it in your calculator and then just give a quick sketch. What does it look like overall on the grid or the coordinates there? So what you would need to do, if we're looking at number 3, it says Madison's parents are concerned that she seems short for her age. The doctor has the following record of Madison's height over 5 years. Using technology, sketch a scatter plot for the data. So we're looking at age and we're looking at height. Now between the two of those, which one would most likely be the explanatory and which one would be the response? Age would be explanatory, height would be response, right? So the older you get, the taller you should get. So what you're going to do in your calculators, you're going to go into your lists. You're going to enter the ages in list 1, explanatory always in list 1, response in list 2. Make sure you keep them in the same order. Those pairs have to go together. So at 36 months, she was 86 centimeters. Those 2 points have to stay together. So get those entered real quick. Okay. So once you have your data entered, you want to create the scatter plot on your calculator. So you're going to go to your stat plot, so second y equals. You're going to choose plot 1. Make sure it's turned on. And then as far as the graph choice is concerned, the one you want to choose for a scatter plot will be the very first option. So when you scroll down to those graph choices, you want the very first option, hit enter. It's going to ask you what you want to use for your X list, what do you want to use for your Y list. So X list should be list 1, Y list should be list 2. And then how do we always get a statistical graph? What do we have to hit there? Zoom 9. So if you hit zoom 9, now you should get a picture of your scatter plot. Everybody there? So what you would do then, as far as the sketch goes, what would we label our x-axis with? age in months. You still need a label. Okay, it's a graphical display. So age in months, y-axis would be height in centimeters. Make sure you always put the units with it. And then all I need you to do is draw the sketch. So what you see on your calculator screen, just give a decent sketch of what that looks like on the grid there, and that's all you need to do. Okay, so you're going to draw the little boxes if you have boxes for your picture, if you have crosses or dots. I just need to know what that looks like from your calculator. And on any problem where it asks you to provide a sketch or it asks you to do something where you had to use a graph to see it, you always need to provide me a sketch. Okay, so you need to actually draw what you see on your calculator. Okay, so that's how to do scatter plots on your calculator. Any questions on that? All right, so time is yours. Use this to work on finishing up. Like if you have to finish up page 161 still or 159, get those done. Otherwise, you can work on the worksheet. I'll post the answer key to that here in a couple minutes, so you can check your work as you go there. If you have questions on anything, now would be a good time to ask. If you're not understanding something that we've talked about in the last couple days, get that figured out now while you have some time.